Hi, and welcome to this video. In the next 5 minutes, we are going to demonstrate how network and cloud engineers can operate a Cisco ACI environment with HashiCorp Terraform. Terraform has emerged as the most popular tool to embrace infrastructure-as-code. With a powerful and flexible network API like Cisco ACI, it becomes possible to operate any data center or cloud in a way that is aligned with principles such as net DevOps and DevSecOps. In the first part of this demo, we are going to illustrate a consumer-provider model where a network operator needs to deploy a new virtual port channel in the local data center. The network automation engineering team has already created a Terraform module to handle that workflow. On the screen, you can see the required ACI resources represented as code with Terraform. These resources are grouped into a Terraform module, which is provided as a black box to the network operator. The module is therefore reusable for all future VPC deployment requests. As opposed to traditional network automation framework, such as RESTconf and netconf, a model-driven network like ACI is a perfect ally to Terraform, as Terraform only needs to communicate with Cisco APIC and not to individual switches. This means that the input that are currently displayed on the screen only needs to be filled once, and every time a new VPC will be requested. A Terraform module is actually comparable to a function in programming language. It takes a set of parameters as input and returns a discrete number of output values. These values can then be consumed by other Terraform environments or other teams. For each of these environments, Terraform maintains a state where root module's output values are recorded. By using Terraform Cloud, which is displayed here, or Terraform Enterprise, the network automation team can provide an easy way to consume modules for network operators by publishing them in a private registry. In our example, the module that has been created allows network operators to provision VPC configuration in a dry fashion, which stands for don't repeat yourself. Using the Terraform design configuration, the user can directly generate the ACI workflow from the module. And as you can see on the screen, there's also an option to enter the variables for that particular iteration, or you can specify them in a separate Terraform variables file. Finally, you upload the generating plan on a version control system so you can directly run it from Terraform Cloud. After creating the Terraform Cloud workspace based on the repository I've just mentioned, the network operator is ready to run Terraform plan. If there are no errors, the plan can then be applied and the infrastructure components will be provisioned. The state file can now be accessed programmatically by specifying the current backend information in a Terraform plan, or you can also directly take a look at it from the user interface. This concludes our first demo. The second use case is the deployment of an application that will sit in AWS and will be accessed from VDI stations living in an ACI fabric on premises. To deploy that application, we're going to use the Cisco multi-site orchestrator provider for Terraform. In addition, this time we are going to run operations locally, but still leverage the remote backend in Terraform Cloud to host our state file. Once again, the Terraform plan is hosted in a GitHub repository, so we can map it to workspace in Terraform Cloud. This ensures a proper locking system for the state file, as well as a single source of truth for our infrastructure-as-code initiatives. As MSO can manage both APIC on premises and Cloud APIC in AWS or Azure, it also means that the corresponding declarative resources must be created in Terraform. Here, the MSO Cloud and on-prem sites have already been added, and we're going to use them as existing references to build upon. But we need to create the remaining construct in MSO. This includes schemas, templates, and then site-specific configuration. When we deploy the MSO configuration to our sites, the local controllers, APIC on-prem and CAPIC in AWS, will translate the MSO configuration into the site native language. So our stretch Hybrid EPG will be deployed as a standard EPG in the ACI fabric, but it will be mapped as native AWS security groups in the cloud. Most importantly, the cloud admin can now deploy programmatically an extended security zone using both ACI Anywhere and Terraform. This time, we are going to run Terraform plan and Terraform apply locally, although no local state file is stored. At the time the construct get provisioned in MSO, you can choose to keep them as configuration elements only and deploy to sites later, or you can directly deploy to sites. This is done by configuring a Terraform resource we have created for that purpose. In the last part, we're going to take a look at MSO to double check that all objects have been provisioned. We had initially only added the two sites, on-prem and AWS, letting Terraform provision the schema and the application template. You can also see that Terraform has created the tenant we asked for and has attached the two sites to it. Now let's take a look at the schema. We can see that a template MyApp has been created and deployed to both sites. What is important to note here is that depending on the nature of the site, there will be specific customization for the template. And you need to handle this in Terraform as well. For example, there is no notion of bridge domain in the cloud, and a bridge domain, and therefore layer 2 network, cannot be extended in the cloud. In the same way, the ACI pervasive gateway is only relevant on premises. In AWS, the gateway will be an AWS object. Finally, EPG classification is also specific to site. Traditionally in ACI, an EPG is classified as port plus VLAN, but in the cloud, classification can be much more dynamic, using zone, region, IP addresses, or even tag. That concludes our video for today. With these two demos, we've seen that regardless of the form factor and location, ACI provides a robust API, which combined with the power of Terraform Cloud or Terraform Enterprise, can deliver the ideal workflow builder that can be leveraged by multiple teams simultaneously in a provider-consumer model, and driven by GitHub in a declarative fashion. Thank you very much for watching, and see you next time.